Dear friends, today we will discuss combination of a capacitors question. Okay, a lot of questions we have to discuss. So first I'm just reminding you the formulas of series and parallel combination of capacitors. All of you know series combination. What is the formula in series combination? Series combination formula 1 by C is equal to 1 by C1 plus 1 by C2, and parallel combination formula C is equal to C1 plus C2. Okay, also this you can write C is equal to C1 C2 by C1 plus C2. So this is series combination and this is parallel combination. Based on these two formulas are simple but circuits are complicated. So we'll discuss effective capacitance we'll find, net capacitance we'll find of many more circuits. Let's first start from simple. Start from simple circuit. Okay. Suppose if I give you one circuit, this is the circuit. How many capacitors are here? 3 capacitors are here. Each capacitor you can take 1 microfarad. Suppose 1 microfarad is capacitor. So how they are connected? They are connected in series connection, because positive plate, negative plate of one is connected to positive plate of other, then negative plate of one is connected to positive plate of other. So they are connected in series. How can you know whether it is series connection or not? If positive plate, remember this line is important. If one plate of one capacitor is connected to other plate of another capacitor directly, then that is series connection. Okay, this one you see, one plate, this is one capacitor, this is another capacitor. It's one plate is connected to the another plate of another capacitor directly. What do you understand? What the meaning of directly? If another wire I will take here, suppose another wire is going like this from this point, is this connected directly to this plate? Not directly. This is not called direct connection. Remember, if one wire will go like this, somewhere that wire will go, then this connection is not direct. They cannot be considered as in series connection. In what connection they are, we will see. But they are not connected in series connection. This one you mark. It's not that they are in a line, so they are in series connection. No. If one plate is connected to the plate of other capacitor directly, then that is only series connection. Okay. So this is now series connection. I will find the capacitance. No, I will not find. You will feel bad because I know you can able to easily find this answer. Okay. You can do it, no problem. Using the series connection formula, you will do. Then this connection. Now see, connection is this. What happens here? This is which connection? Which connection this is? Obviously parallel connection. There's just one after other. They are in a line parallel to each other. This is a parallel connection. Okay. So if you parallel connection, you can use this formula. C is equal to C1 plus C2. But remember, they are in line, one, then another, then another. That is not only called parallel connection. Then you may do mistake if you understand in this way. Then how will you understand whether they are in parallel or not? If positive plate of all capacitors are connected to one point, negative plate of other capacitors are connected to another point, then this connection is parallel. Don't keep in mind parallel means one, then one, not like that. If positive plate of all capacitors are connected at one point, negative plate of all capacitors are connected at another point, then this is called parallel connection. Or another way also I can tell you, this capacitor terminal A and B. So potential difference is VA minus VB. Its terminal A and B, its terminals A and B. So if all capacitors terminals are same, then also this is called parallel connection. Means potential difference remains same in all capacitors. But don't keep in mind one by one, not like that. Understand? Okay, as they are in parallel connection, you will use the formula C is equal to C1 plus C2 plus C3. Take each capacitor as 1 microfarad. I will not tell you the answer. I know you will feel bad because this is a very easy question. Then I will go to next. Little bit. Now you see, this one you see, one capacitor. This is one capacitor. This is one capacitor. Okay, they are connected like this. 1 microfarad, 1 microfarad, 1 microfarad. So, what is the effective capacitance between point A and point B? Now what you have to do? This also seems to be easy. But here, these two capacitors, how they are connected? They are connected in parallel. How they parallel? Because their terminals are same. Their terminals are same, so they are parallel. Okay. So as they are parallel, what is the effective capacitance? I am just redrawing the diagram now. See, let's redraw this one, making it simple. 1 microfarad, 1 microfarad. As they are parallel, what is the total capacitance? Parallel formula C equal to C1 plus C2. So this is 2 microfarad. Okay. 1 plus 1, 2 microfarad. Then 1 and 2, how they are connected? It's very clear. They are connected in series. So as they are connected in series, you will find the formula. What formula I told you? If 2 are there, just write this one, C1 plus C2, C1 into C2 by C1 plus C2, then 2 by 3. This is microfarad. Okay, then you can solve it like this. This is also very simple one, but I did it, no problem. Now we'll go to the next connection. Now see this one. If the connection is like this, then what is this connection? This connection is series connection. Okay, because one, then another, then another. Okay, this is series connection, very clear. But what happened? If I connect one wire like this, now what happens here? What is the capacitance? I am connecting one wire here. Point A, this is point B. Now what is the capacitance? I am connecting only one wire. What happened? Now you see, dear students, here 1 microfarad, 1 microfarad, 1 microfarad. If I connect one wire here, then these two capacitors become short. They will not be considered. Okay, their capacitance will not be considered. These two capacitors become short now. Whenever any current will keep, that current will go like this. That current will go in this path. Because current always prefers low resistance path. Where there is no opposition, current go through this line. If one capacitor, suppose you connect one wire like this, then these two capacitors now cut from the circuit. Need not be worry. Now what is the total capacitance? It's very simple. Direct answer 1 microfarad, because only one remain. Only one capacitor remain. So that is 1 microfarad. If anywhere this type of concept comes, one wire go like this, then the capacitor, that portion become short. Now you come, suppose in the same diagram. Next question we will do the same diagram. How they are connected? In series. But I will modify it. See, I am just modifying the diagram. I am connecting it here. I am connecting it here. Understand? Between point A and B, we will find the effective capacitance. Is 1 microfarad. Okay, this is one capacitor, two capacitor, three capacitor, each 1 microfarad, 1 microfarad. What is the effective capacitance? In this case, you may see one wire is gone like this, these two become short. One wire is gone like this, these two become short. Then everything, all capacitors are sorted here. So net capacitance 0. No, not like that. I had told you if one wire go like this, then they become short. But another wire also start from the middle. Now you cannot consider them as short. You just see the previous diagram. Okay? If only one wire go, if only one wire, this wire is not there, then they are short. But if another wire will come like this, then they are not in short circuit. Okay? Then what happened here? Then you can see this capacitor, they are in series. Are they in series? First capacitor and second capacitor? Just before also I told you they cannot be also in series. How? Because you see the one plate of this, suppose you make the plates now. Okay, this is positive plate, this is negative plate. Suppose you make. So one plate of this capacitor is connected to the other plate of the capacitor. Is it directly? No, I have told you. Series connection means connection should be direct connection. But here it's not directly, so they are not in series connection. Then what we'll do? Take this terminal now, we have to think about it. What to do now, we have to think about it. Okay, so this is now positive terminal you take, this terminal you take negative, because if two terminals are there, one must be positive, other must be negative. Positive is connected to this plate, it is positive. Same positive wire you see how the marker is going. Again you see how the marker is going, same positive wire is going. And so this is positive, also this is positive. This is negative, so this is negative. And same negative wire is going, you see, negative wire is going, this is negative, okay, and this is negative. I hope you can able to understand how I make the plates positive and negative. Okay, positive go like this, so it is positive. Negative wire go like this, so it is negative. Now you understand. So what is the connection? Now you see this capacitor, first capacitor positive plate is connected at A, second capacitor positive plate is connected at A, third capacitor positive plate is connected at A. See, first capacitor negative plate is connected at, you see negative plate like this goes connected at B. Second capacitor negative plate is at B. Third capacitor negative plate is at B. Understand? So that means all capacitors positive plate is connected to A, negative plates are connected to B. So how those capacitors are connected? What this connection is what? Just before I told you, don't keep in mind parallel means one like this. Parallel means if all positive plates are at one point, negative plates are at one point, then the connection is called parallel connection. So these three capacitors are in parallel connection. Okay, then you can find the effective capacitance. 1 plus 1 plus 1, it is simply 3 microfarad. I hope you could be able to understand now. So this is the parallel combination of capacitor. In this way we can do. Now we'll go to the next question. Suppose I am doing now, all of you see the next one. Next one is like this. Okay, make one triangle. So make a figure like this. One capacitor here, one capacitor here, point is A, one capacitor here. This is which connection? This one is which connection? Let's see. A point is positive, B point is negative. A wire now goes to which plates now, all of you see? A wire, positive wire goes to this plate, this is positive. Positive wire also goes like this. This is positive. Also goes like this. This is positive. This is negative. Then this plate is negative. Then that negative wire goes like this. This is negative. This is negative. I hope you could able to understand. Negative now goes like this. This is negative. This is negative. This is negative. Then this is positive. 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 What happened here? Which connection this is? All positive plates are connected to A. All negative plates are connected to B. So this is nothing but parallel connection. Parallel connection. Only the figure is confusing you. Otherwise it is parallel connection. These wires only in extent. These are the useless wires. They are not required at all. Okay. If you cut these wires and connect this point to this point, and cut this wire, connect this point to this point. Okay. The figure will turn like this. You see. You cut this wire because this is just the extension of wire. This is just the extension of wire. If the figure turn like this capacitor will go to up, this capacitor will come to down. This will remain in the middle, and the connection will be look like your parallel 1, 1, 1 like this. Okay. So this is one connection. Now I'll go to the next connection. Next connection. Let's see. Suppose next connection is this one. Parallel, you will write the answer like this. Next connection, so it is like this. Okay, so here one capacitor, here one capacitor, and here one capacitor. Here is A plate, and here is, and here is one plate. No plates are here. One plate is here. P, one end is here, one end is here. Okay, ends are here. Then this is switch connection. Also it's very clear. It's parallel connection. Okay, only this wires extend and position of capacitor come here. If I erase the capacitor from this position, I will take it to this position, no problem. I will erase it from here, I will take it to this position. Okay, so it's very clear. 3 capacitors are connected in which connection? Parallel connection. What is the effective capacitance? If 1 microfarad each capacitor, then totally is 3 microfarad. Simple answer this is. Now I will go to the next connection. Next connection, let's come. Okay. So next connection is like this. Suppose now many capacitors are connected here in this. One is connected here. One is connected here. Then the wire goes. Then the wire comes like this, wire comes like this. Okay. Then one capacitor, this is the terminal, this is the terminal A, this is the terminal B. Now one capacitor is here, another capacitor is here, and here also some capacitors. One is here, one is here, then here is also one capacitor. Okay. So if the circuit is like this, it looks like one complicated circuit. One capacitor is also here, but it's very easy to solve. Very easy to solve this one. Just if this type of figure come, try to solve the branches. Okay, what branches? You redraw the figure. Redraw the figure time and again. You redraw the figure. Okay. Suppose this capacitance is 1 microfarad. So these two are connected in series because it is a direct connection, series connection. You now redraw it in series connection. Now 1 into 1 by 1 plus 1, it becomes 0.5. Replace this as one capacitor. Okay, so now it becomes 0.5. This is also 1. Now this 1 and 0.5, how they are connected? They are connected in parallel because you see the terminals are same, so they are connected in parallel. Now you erase this one, this become now one capacitor, 0.5 become 1.5 microfarad. Now come to this part, this is one, there also is connection, parallel connection. You now erase this one, you in place of them you replace one capacitor. What is the capacitance? 1 plus 1, 2 microfarad. Then 1 and 2, how they are connected? In series. If they are in series, now you shall 1 into 2 by 1 plus 2. So now you make in place of them, you place one capacitor, 1 into 2 by 1 plus 2. So 2 by 3 microfarad. Okay. So now, and this one, they are in which connection? They are also in series connection. If series connection, now you can do this. This is 1 into 1.5. This is, or you make it, it's 3 by 2. So this is 3 by 2. So series connection, so 1 into 3 by 2 by 1 plus 3 by 2. So it will become 3 by 2. Then this is 5 by 2. It is coming 3 by 5. I hope the mathematics is right. Okay. 2, this is 5 by 2, then 3 by 5. So now these two erase, and in place of them, now you place it 3 by 5 microfarad. Then how these two are connected? They are connected in parallel. So 3 by 5 by 2 by 3. Now you add this. They are connected in parallel. So now you erase this, and in place of them you make one capacitor. This is the one capacitor. Okay, and you add them. This was, I think, 2 by 3, and this is 3 by 5. You add them. This is the microfarad. Then this one is again connected with 1 microfarad in series connection. Solution is yours. You will add it. Then after that, with 1 you will do series connection. You can do this. If this type of circuit come, you will solve the different branches, small branch you will solve, and you will always redraw the figure. Okay, make it more simpler so that you can able to do. Now I will go to the next question. It's also very interesting one. Interesting question. Now you see this one. 3, 3, 3. Okay, one capacitor. This is one capacitor. This is one capacitor. 3 microfarad. It's 3 microfarad. This is 3 microfarad. Then here is 2 microfarad. Then here again 3 microfarad. Then here again 3 microfarad. Okay. Then also it's not complete. Again this branch is continuing. This is again 2 microfarad. Then 3 microfarad. Then 3 microfarad. What happened here now? See, these are the two terminals, P and Q. We have to find the effective capacitance between P and Q. What will do? Let's solve this question from the back. From this side you start solving this question. From this side. I told you, small branches you will cut. You will just cut small branches. Okay. So 3, 3, 3. How they are connected? They are directly connected in series. Okay, so 3, 3, 3. What is the connection now? So now this is 1 by 3, 1 by 3, 1 by 3. In series connection, this is the formula I put. So it becomes 1. So C is equal to 1 microfarad. So now you cut this branch. In place of that, you write 1 microfarad. 1 microfarad, 2 microfarad, which connection now? Parallel connection. If they are parallel connection, so what is the effective capacitance? Now just add them so that we will get the answer. 1 plus 2, 3 microfarad. Okay. Then 3 microfarad, 3 microfarad, 3 microfarad. It's repeating. Okay, it's repeating again what I discussed just before. Means they behave like one capacitor of 1 microfarad. 1, 2, parallel connection, again it repeats. Okay, we have like one capacitor of 3 microfarad, 3, 3, 3, again series connection, again it repeats. What is the answer? 1 microfarad. Understand? So the total answer of this question, final answer of this question is 1 microfarad. This is also very easy one, not so difficult. Then next come to the next question. That is also important one. It's also a very interesting one. Let's see the question like this. Question like this. It is new for you. Okay. So now let's see. Here is one capacitor. Here is one capacitor. One capacitor. one capacitor, one capacitor. Terminals P and terminal Q. Each 1 microfarad. How will solve this 5 capacitors? This and this, how they are connected? They are in series connection. If they are in series, see, these two are in series connection. They will connect it like this. Are they in series? No, they are not in series. Why? Because the middle one is connected here. One wire comes through this. So these two are not in series connection. Okay. These two are in parallel connection. Are they? No. They are not in parallel. They are one terminal is at one point. One terminal is at one point, but the other terminals are not in same point. Not in series, not in parallel. How will solve this question? How will solve this question? This question will be solved by Wheatstone bridge condition. Whenever this type of figure you will see, it's called Wheatstone bridge. Wheatstone bridge. And this Wheatstone bridge will be explained in current electricity chapter. In current electricity resistor combination, we will discuss all theory of Wheatstone bridge. But just I am telling you the answer. You just see here what we will do in these cases. If these cases will come, let's do the capacitor naming. This is P, this is Q, this is R, this is S. P, Q, R, S. What happened? There is a balanced condition of Wheatstone bridge. This type of combination is called Wheatstone bridge. Okay? There is a balanced condition. What is the balanced condition? P by Q equal to R by S. Is this condition satisfying? If this condition satisfies, then this connection, then what happened here? If this condition satisfies this capacitor, you just erase, because this capacitor has no role. No current, nothing passes through that capacitor. P by Q is equal to R by S. Then this capacitor you cut from here. Okay? Is this condition satisfying? First you check. Without checking you cannot erase. You first check. P by Q, 1 by 1 it's 1. R by S, 1 by 1 it's what? 1. So this condition satisfying. So you erase this capacitor now. Already I have erased it. Now the connection is easy. How they are connected? How this P and Q are connected? Direct connection now. They are in series connection. How R and S are connected? Also they are in series connection. So 1 microfarad in series connection, that become 0.5, and also this R and S in series connection become 0.5, and 0.5 which connection? It become parallel connection. The final answer is 1 microfarad. 1 microfarad. This is the effective capacitance of this Wheatstone bridge connection. Understand this one? Then we will go to the next question. Okay. Now let's see the next question. Next question is like this. What happened? Next question is like this. You see, it is like this. One is here, one is here, one is here, and one is here. Each 1 microfarad. What is the capacitance between P and Q? See the figure. Okay? Can you able to find out? Or you are there now thinking, sorry, you are checking, only you are, what you are doing, you are only the straight line you have made it curve. Okay? Otherwise this figure is just the same as the previous one. So nothing to discuss. Okay? Just only the straight lines I make it curve. Otherwise, now you see, already you have done it. Just before I did, which connection? Wheatstone bridge. Satisfy balance condition or not? You have to check first. P by Q equal to R by S. It's equal. So this capacitor you neglect. Then 1, 1, it becomes 0.5, 1, 1, 0.5, 0.5, 0.5. It becomes total capacitance is 1 microfarad. Now we go to the next question. You see, next question is like this. This is one capacitor, this is one capacitor, this is one capacitor. Okay, They are connected like this. Each 1 microfarad, 1 microfarad, 1 microfarad. If this type of connection, I think we have already done it. All three are in parallel just before I told you. But I am making it little difficult, you see. Now what happened here? If I connect like this. Here is 1 microfarad, here is 1 microfarad. This is A, this is B. Okay. Now how will solve this question? Now it seems to be difficult. How will do this one? How will do this question? Now let's see. How will solve this question? Okay, it's not any difficult one. Already we have done it. We have done it. Where? Just before. This is nothing but Wheatstone bridge. This connection is nothing but Wheatstone bridge. Now the question is coming to mind, sir, please show how it is looking like Wheatstone bridge. Wheatstone bridge is like this, but it's not looking like that. Then how it is Wheatstone bridge? Now see, I am drawing you your Wheatstone bridge diagram and I am comparing it. You see, okay, this is your Wheatstone bridge diagram. Okay, now you see this one. This capacitor I told you P, Q, this is R, this is S. Okay, P, Q, R, S. This one is to die. We will cut it. Okay, this capacitor. Okay, so now see this terminal is A, this terminal is B. From A terminal, how many capacitors start? 2 capacitors. How many capacitors are there? 2. P and R. You see from A terminal, how many capacitors now are connected to terminal A? 2 capacitors. I name it P, I name it P, I name it R. Understand? Terminal B. How many capacitors are connected? 2 capacitors, Q and S. You see terminal B. How many are connected? 2 are connected. Okay, 2. You see here also 2, here also 2. Q and S. Okay. This capacitor is connected where? Let's PQ common terminal. This is PQ common terminal. I put on tick mark. PQ common terminal. PQ common terminal is this. I put on tick mark. RS common terminal is this. Okay, RS common terminal is this. I put tick mark. It is connected between 2 tick mark. It is also connected between 2 tick mark. Means this capacitor is going to die. This is going to be cut. This one, here this one will cut. Same thing here also this one will cut. Now see the connection. It's nothing but Wheatstone bridge. These 2 are in series, these 2 are in series, then these 2 series are in parallel. So how I have done the Wheatstone bridge also you will do like that, nothing to be worried. Understand? So this is about the Wheatstone bridge connection. Now we'll go to the next connection, capacitor connection. This is infinite capacitor series. Infinite capacitors are there. In that case, what will do? Okay, now let's see. 1 capacitor here, 1 capacitor here. Then 1 capacitor you can connect also here. Here 1, here 1, here 1. Okay, 1 here, then 1 here, then 1 here. Like this, how many capacitors are connected? Infinite number of capacitors are connected between the terminal A to B. Each capacitor is 1 microfarad. It seems to be difficult if infinite number of capacitors are there, each 1 microfarad. Total capacitance also should be infinite. Should be infinite or not? No, total capacitance is not infinite. If not infinite, then what's the answer? Let's try to solve, no problem. But before solving it, I'm telling you one thing. Large amount of water is there in C. Okay, large amount of water is there in C. Suppose you will bring a glass of water from C and drink. I know sea water you can't drink. Okay, suppose you drink 1 glass of water from sea you bring and drink it. Okay, or you take it to your home, sea water. Okay, then what happened? Is there any change in level of water in the sea? Okay, your answer is no, because the sea is so large. One glass of water, what it will do? Infinite amount of water is there. One glass doesn't matter. If you pour one glass of water, suppose from home you have taken some water. From home, suppose you have taken one glass of water and you are now going to the sea. Okay, you are now standing near the sea and you pour one glass of water in sea. What happens to water level? Immediately water level will increase and tsunami will come. Also not like that. There is no change in level of water. Infinite amount of water, you add one glass, doesn't matter. You take one glass, doesn't matter. The same principle also will apply here. Now try to understand. Many capacitors are there. I don't know what is the capacitance. Let X is the effective capacitance. What is the effective capacitance? X. So X is our question now. We have to find out X. Let X is the effective capacitance. If X is the effective capacitance, means all capacitors capacitance is X. Understand? All capacitors capacitance is X. Keep in mind this one what I am telling you. What you do now, this figure is repeating again and again. You see, time and again this figure is repeating. 1, 2, 3, 1, 2, 3, 1, 2, 3. You do one thing. Now we'll first just remove this 3. This 3 first we remove. Okay. Now let's remove this 3. If we remove this 3, is there any problem to our capacitors? Infinite capacitors are there. If we remove only 3 capacitors, one segment if we remove from this, suppose I remove. Okay. I remove this 3. Now I am hiding this 3. How many capacitors are there? Infinite minus 3 is equal to still infinite. Still infinite. Removing these 3 capacitors will not affect. Okay, no problem. Still infinite capacitors are there. If again infinite capacitors are there here, what will be the effective capacitance of these infinite capacitors? What I erase? That is also X. That is also X. Okay. That is also what? X. Infinite capacitors capacitance is X. We have already told. Okay, we already know this. Now you do one thing. You pour one glass of water in sea. If I add this 3, then also there will be no change. There will be no effect. Okay. Again also the capacitance is, total capacitance is X. If I add this 3. Okay. This was initially we have taken all these capacitors capacitance as X. I remove 3, also it is X. If I add 3, also it will be X. Now let's see. Now you add this 3. If you add this 3, 1, 1, this is 1 micro, 1 micro. Okay. So now what happened here? These two are which connection? These two are parallel connection. With these two, it is which connection? Series connection. Parallel connection means 1 plus X. Then with this series connection, then what is the total capacitance now? 1 by 1 plus 1 by 1 plus 1 by 1 plus X. 1 by 1 plus X. Okay. But this total capacitance we have discussed, it is 1 by X. Total C is X. Total capacitance is X. Okay. Adding this 3 doesn't matter. So net capacitance is also X. So this is 2 plus 1 by 1 plus X. What you are getting now? If you now solve it, you will get one quadratic equation. One quadratic equation you will get. After getting quadratic equation, you can't able to solve it. You know, I never do mathematics part. Okay, I also will leave you this one. Okay, you will do the quadratic equation and you solve it. You will get how many values of the quadratic equation? 2 values. One is positive, one is negative. You know that minus b plus or minus b square minus 4ac root over divided by 2a formula. You will get 2 values, and positive value is possible, negative value is impossible. So final answer will be 1, that is the positive value. You know, capacitor cannot be negative. This is infinite capacitance formula. Then we will go to the next capacitor, let's see. Okay, now if the plates are like this, one plate is like this. These are actually plates. Okay, these are not lines, these are actually plates. Okay, so for terminal A, terminal B, these gaps are same. D, this is also D. Plate area, this is A, this is A, this is A, this is A. What is the effective capacitance? Then you are thinking they are not looking like capacitors. Yes, they are capacitors. One capacitor plate like this, you see. The plates, I am showing you these plates. This plate is like this, one. Another plates like this, you see. Two plates are there. Okay, so these are plates. This is the plate area. This is not a line. Okay, so plate area. So how many capacitors are here? First check. If this is positive, this is positive, positive, this is positive, positive. If this is positive, then this is also positive. If this is negative, one terminal will be negative. This is negative, 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 negative. What happened here? This is one capacitor. Plus minus plate separated by finite distance. This is one capacitor, 2. This is one capacitor, 3. How many capacitors are here connected? 3 capacitors. And how these 3 are connected? One first capacitor positive A, negative B. Second capacitor positive A, negative B. Third capacitor positive A, negative B. So how they are connected? In series or in parallel? Okay, they are connected in parallel because all positive A, all negative B. And what is the capacitance? Just 3 into epsilon naught A by D. 3 into epsilon naught A by D. Parallel connection, 3 capacitors, just addition. Okay, so this is the figure. But in the same one, it may give like this. One capacitor is like this. Another capacitor is like this. Okay, this is terminal A, terminal B. This is positive, 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 positive. Let's do positive first. Before that, D. Gaps are same. Plate area is A. If this plate is made positive, then this is positive. This is positive. If this plate is made negative, this is negative, negative. This is negative, negative, negative. Okay. So how many capacitors are here? This is one capacitor. This middle one, is it a capacitor? No, because here positive plate is here. Positive negative plate should be capacitor. Positive negative separation, but positive it's not a capacitor. This is another capacitor 2. So how many capacitors form here? 2 capacitors form. 1 and 2. Okay, and how they are connected? They are connected in parallel. All positive at A and all negative at B. So capacitance is 2 epsilon naught A by D. So this is also parallel connection, and this type of figure also will complete. Now I'll go to the next one. Let's see. Okay, it's also one interesting one. Next figure. Capacitor is like this. This is one capacitor. Second step, 2 capacitors are there. Then in third step, 4 capacitors are there. 1, 2, 3, 4 capacitors are there. Then in second step, how many? 8 capacitors are there. I am not doing the figure. 8 capacitors are there. Okay, 8 capacitors. They are connected like this. Okay, they are connected like this. And this is the terminal. This is terminal A and terminal B. How they are connected? Now let's check. I have told you when complicated circuit come, try to solve the branches, try to cut the branches. This branch capacitance is, this is C. This is how much? C, suppose you take this is 1. So in question it will give, this is given 1 microfarad. It's 1 microfarad, how they are connected in series? So it becomes 1 by 2. Okay, 1 by 2 microfarad. These 4 are connected in series. If you solve them, you will get 1 by 4 microfarad each one. So 1 by 4 microfarad. This 8 if you solve, you will get 1 by 8 microfarad. So all branches you first solve, and it extend up to infinite. And how they are connected? All are connected in parallel. You see, these are the two terminals of all capacitors. So what is the total capacitance? Just addition, 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 dot dot dot. So what it comes? How you add it? It's very up to infinite. It's a long addition. No, it's not long. We have done also many questions like this. It's nothing but 1 GP. Symmetric progression. So addition is A by 1 minus R. R is the common ratio. You see the common ratio is coming half, multiply. Okay, A by first term divided by 1 minus common ratio. The answer is very simple. It is coming 2 microfarad. Very easy answer of a very complicated circuit. You can solve it infinite capacitors. Then we'll come to next question. Now come to the next question. Okay, let's come to the GaN capacitor. What is this GaN capacitor? One capacitor suppose has many plates, 1, 2, 3. Okay, many plates all are equally separated, and one plate also comes from them. They are also equally separated. Okay, so one plate is here. So it's called GaN capacitor. So this is connected to one terminal P. This is connected on the terminal Q. Now you see what happens here. Okay, so if this P is positive, this is positive. These are positive. Positive. If this Q is negative, 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 negative. This is negative. This is negative. Is it clear? Here, these are not lines. These are one plates. Okay, means one negative plates are from the down, positive plates are from the up. This is called GaN capacitor. It is also treated as one variable capacitor. Its capacitance will vary. If this P point will go up and up, the area, common area will decrease. So capacitance will vary. Wherever variable capacitors are required, it is used. It is called GaN capacitor. Okay. So now how many capacitors are formed? You see 1, 2, 3, 4, 5, 6, 7, 8, 9. How many capacitors formed here? 9 capacitors formed, and all the 9 capacitors, how they are connected in parallel. So total capacitance is parallel, all positive at P, all negative at Q. 9 into epsilon naught A by D. This is called GaN capacitor. Okay, what you mark here? So from P, how many now bars come? 1, 2, 3, 4, 5. Okay, 5 bars come here, and the capacitance becomes 9 into epsilon naught A by D. Suppose n number of bars will come, then how will find? N, this is 5 bars, is coming 9. Okay, accordingly you can also find it if there will be n number of bars. Okay, accordingly how much will be the capacitance, then you can able to see. Understand? Okay, so now let's come to the next one. So this is about the GaN capacitor. Now we go to the next one. Next one is also very interesting one. This question came in 2017 CBSE sample paper question. This is step capacitor. Okay, this step, this is D. It's just looking like your staircase. Okay, this area is 3A. This is A. This is A. This is A. What is the capacitance of this? If this type of question will come, what will do? This is the 2017 CBSE sample paper question. Okay, may come in board exam. Okay, try to prepare. So how many capacitors are here? This is positive plate, means whole plate is positive. This negative plate, whole plate is negative. Okay, this is one capacitor looking like, but gaps vary. Accordingly, so we'll divide them. We'll make them 3 capacitors. Okay, here up to this one, up to this 2, up to this 3. Okay, 1, 2, 3. First side, for first capacitor, what is the formula? Epsilon naught A by D. Second capacitor, what is the formula? Epsilon naught A by 2D. Separation D plus D, 2D. Then third capacitor, what is the formula? Epsilon naught A by what? 3D. Understand? And how these capacitors are connected? It's obviously they are connected in parallel. All positive at one point, all negative at one point. parallel connection, so net capacitance is C1 plus C2 plus C3. You know, I will not add, okay, that is up to you. You will add them, just simply add them, nothing to do. This is a very easy question, came in 2017 CBSE sample paper. Okay, also one question I will give you. Next one will go to dielectric division capacitor question. It's also very important one. Dielectric division. What dielectric division? In one capacitor, but dielectric will be two. Capacitor is one. This is one dielectric, this is another dielectric. Capacitor is one, this is one plate, this is another plate of the capacitor, PQ, two plates, two terminals. But dielectric here is one. Okay, this part dielectric is K1 and this part dielectric is K2. If you two dielectric, then how will write the formula? If you one dielectric, then we know K epsilon naught A by D. K epsilon naught A by D. But here two dielectrics. Okay, this is half divide. The whole area is A. This area A by 2. Here area is A by 2. And separation is D. Two dielectric. Then we'll treat them as two capacitors. Problem solved. You treat them as two capacitors and see what is the combination. Here area divide. Area divide A by 2, A by 2. Okay. Just to treat them as two. This is one capacitor. This is one capacitor. So C1 K1 epsilon naught A by 2 D. Area divides A by 2. C2 K2 epsilon naught A by 2 D. This is A by 2 D. Understand? Okay. How they are connected? Let's see. This is one capacitor. This is one capacitor. Okay. So this is connected. This plate is positive. If this plate positive, this plate positive, because it's connected to one terminal P. Positive plate means they are connected to one terminal, that is P. Here also connected to one terminal, that is Q. Now you see, this is C1, this is C2. See this figure, how these two capacitors are connected. It's very clear they are connected in parallel. Okay, this is positive connected to P, negative connected to Q. The parallel simply C equal to C1 plus C2. Then what will do? C1 is K1, then epsilon naught A by 2D, then this is K2, epsilon A by 2D. Okay, then it is coming K1 plus K2 by 2 whole into epsilon naught A by D. Understand this one now? Okay, so this is about the total capacitance of this capacitor in dielectric division. Also, you can find equivalent dielectric constant. Then you are thinking, sir, you are telling about equivalent capacitance. Now also you are discussing about equivalent dielectric constant. Yes, you see, you can remember equivalent dielectric constant. Now, this up to this capacitance is over. We got, but now you can get it equivalent. Suppose this is one dielectric. You just take as it is one dielectric of dielectric constant K. So this one answer K1 plus K2 by 2 whole into epsilon naught A by D. Then this is cancelled. What is the equivalent dielectric constant now? You see K is equal to K1 plus K2 by 2. This is the equivalent dielectric constant. If the dielectric is taken like this, dividing area of the plate. Okay. Now the question may come to again. If the dielectric is not taken like this, suppose dielectric is taken like this, then what happens? This is one capacitor plate, this is one plate. Dielectric is taken like this. This is one dielectric plate. This is K1. Okay, this is K2. Area is A and separation is D. If separation D, now you see this D separation becomes half. This is D by 2 and this is also D by 2. Then what happens in this case? What will do in this case now? You see, so they are treated as two capacitors again, same thing. C1 I will write K1 epsilon naught A by D by 2. C2 K2 epsilon naught A by D by 2, because here this divide, okay, this distance divide here. I can write this as 2k1 epsilon naught A by D. This is 2k2 epsilon naught A by D. But how they are connected? You see, these are the two terminals, two plates. So first capacitor is this one, second capacitor is this one. This is P terminal, this is Q terminal, Q, this is C1, this is C2. So how they are connected? It's very clear, they are connected in series connection. Okay. So series connection, what is the formula? 1 by C equal to 1 by C1 plus 1 by C2. You just put C1 here, you will get D by 2k1 epsilon naught A plus D by 2k2 epsilon naught A. Okay. Then if you take it, then you take, now what happens to 1 by C? You take common D by 2 epsilon naught A 1 by K1 plus 1 by K2. Okay. Now you take LCM this one. If you take LCM, what happen? K1, K2, if you take LCM, then it is coming to D. This is D by 2 epsilon naught A K1 plus K2 by K1, K2. Okay. This is 1 by C. But don't forget to reverse it. Okay. Because we need C. So C is equal to 2k1 K2 by K1 plus K2 whole into epsilon naught A by D. Now you understand? Okay. This is the equivalent capacitance. But what is the equivalent dielectric constant? If you place in place of K epsilon naught A by D, then this one, then epsilon naught A by D cancel. What is the value of K remain? 2k1 K2 by K1 plus K2. 2k1 K2 by K1 plus K2, equivalent dielectric constant. It will take like this. If suppose many plates are there, 3 plates are there, suppose in between, we can also change this one. In general, we can make this general now. See, K1 plus K2. You just reverse it. 2 by K is 1 by K1 plus 1 by K2. Understand this formula? If n number of separations will be there, suppose n number of dielectrics you will take, you will let n by K, 1 by K1 plus 1 by K2 plus 1 by K3 plus 1 by K4 up to dot 1 by Kn for n number of divisions. Okay. So this is about division of dielectric. Now let's come to the next question. If this division of dielectric, but if it become C, suppose 3 dielectrics now we'll take. We'll take 3 dielectrics, but it's taken like this. K1, this is K2, this is K3, this is K3. You can able to understand, I think. Okay. Now you see what happened. What happened here? This area is A, separation is D by 2, D by 2. Okay. And this is area becomes A by 2, and for this area becomes A by 2. How many capacitors are here? We have 3 capacitors. Okay. And these 3 capacitors, how you solve? How these two are connected? You see the equivalent diagram is like this. Equivalent diagram is like this. I'm drawing here the equivalent diagram, you can check. Diagram is like this. These two are connected, then one capacitor. Understand? These two are connected in what? C parallel, and this one 3. This is C1, this is C2, this is C3. But how fast? If you want to do it fast, then what will do? These two capacitors, you can use the equivalent dielectric constant formula. Otherwise, you write C1, C2, C3. First do them parallel, find the effective capacitance. Then with this you do the series connection formula, you apply. You can able to do it, no problem. So what I did now, so we discuss division of dielectric formula of the capacitors. Okay. And the last figure will not too late. The last figure now, let's see. The last figure is like this. One capacitor, okay, is here. It is connected. The last figure, let's see. One capacitor is connected here. Okay, then one capacitor is here, then one capacitor is here, it is connected, it is here, it is connected. Okay, then one capacitor is here, then one is here. Terminals are, this is A terminal, this is B terminal. So how these capacitors are connected? All our capacitors are same, all are 1 microfarad you take. Now how will do? Understand? How will do this question? You can pause the video here and you can try yourself, then you see the solution what I am telling you. Okay? Don't directly see the solution. Your creativity, your innovativeness will die. You will see the solution directly. So what we'll do here? So you just, these two terminals, this wire is just extension. This is just like extension. Let's connect it here. This wire also just like the extension. This is connected already, no problem. Okay, let's connect it here. What happened? You will see properly. Just to look this figure properly, you hide it. You hide this one and you see these 4 capacitors. It's nothing but Wheatstone bridge connection. This is which connection? Wheatstone bridge connection you see. This one is the middle capacitor which is to be cut. This one to be cut. Okay, PQRS. PQRS. This one to be cut. You will hide this. This is Wheatstone bridge connection. Okay, then you solve it. Then this one will solve it 1, 1. It become 0.5, 1, 1, 0.5. Then 0.5, 0.5 will become 1. Then with this it again connected in what? Parallel connection. Total of the Wheatstone bridge is coming 1 and this is also 1. What is the total capacitance now? 1 plus 1. It become how much microfarad? 2 microfarad, as it is which connection? Parallel connection. Understand? So this is about the combination of capacitors. So today we discuss a lot of circuits about combination of capacitor. I hope you will practice all the circuits, and with this I think we already completed the second chapter of your NCERT book. Then we will go to the third chapter from our next videos.